All right, today we're going to crack the code on a classic GCSE math question, one that's worth a whopping 4 marks. We're not just going to solve it, we're going to walk through the exact steps and, maybe most importantly, see how those steps line up perfectly with the official mark scheme.
So this is the real deal. We've pulled this straight from the May 2024 Pearson Edexcel Higher Tier paper. We're zooming in on question 10, which is all about solving a pair of simultaneous equations. This is exactly what you'd see on exam day.
Okay, so here's our challenge. Question 10. You know the goal here. We've got to find the values of x and y that make both of these equations true at the exact same time. So let's get a good look at what we're actually working with.
Here they are, our two equations. 5x minus 2y equals 23, and 2x minus 3y equals 18. Now, if you look closely, you'll see the first little puzzle. None of the numbers in front of the x's or y's actually match up, and that's where our strategy comes in.
We're going to tackle this with the elimination method. Honestly, it's a super powerful and efficient way to solve these things. And the name says it all, right? The whole point is to completely get rid of or eliminate one of the variables. That'll leave us with a much simpler equation to solve.
So here's our 4-step game plan. It's pretty straightforward. First, we'll decide which variable to get rid of. Let's pick y. Then we'll do some multiplication to make the y parts identical. After that, a quick subtraction makes the y's vanish. And finally, we solve what's left to find x. It's a nice clear path to the answer.
All right, enough planning. Time to get our hands dirty and actually execute this thing. We're going to follow our plan step by step to hunt down the value of x.
Okay, so remember step 2? We need those y coefficients to match. We've got a 2y and a 3y. So what's the smallest number both 2 and 3 go into? 6. So we'll multiply that whole top equation by 3 and the entire bottom equation by 2. This is the absolute key move.
And voila, look what that does. We get two new but equivalent equations. 15x minus 6y equals 69, and 4x minus 6y equals 36. Now check it out, we have a minus 6y in both equations. They're identical, which is exactly what we were aiming for. Perfect. And now for the magic trick, the elimination itself. We're going to subtract that second new equation from the first one. And think about it. When we take negative 6y and subtract another negative 6y, they just cancel each other out completely. They're gone. And once the dust settles from that subtraction, we're left with this beautiful, simple equation, 11x equals 33. We've just turned a complicated problem with two variables into a super easy one with just a single variable. You know, the hard part is pretty much over.
And to solve for x, what do? We just divide 33 by 11. And there it is. X equals 3. Boom. We've got our first value. We're halfway home.
Okay, now that we've got x in our back pocket, finding y is going to be a walk in the park. We're just going to take that value we found and plug it back into one of the original equations.
Let's just use the first one, why not? So that was 5x minus 2y equals 23. We just swap out the x for the 3 we just found. So the equation now reads 5 times 3 minus 2y equals 23.
So let's work this out. 5 times 3 is 15. Then, we subtract that 15 from both sides of the equation, which leaves us with minus 2y equals 8. We are so close now, just one final step. All we have to do is divide 8 by minus 2, which gives us our value for y. It's minus 4. And that is it. We've done it. We've solved the whole thing.
So let's just recap our complete solution. We found that x equals 3 and y equals minus 4. These are the two magic numbers that make both of our original equations true. But, you know, just getting the answer isn't the whole story, is it? How do we make sure we bag all 4 of those marks? Right, welcome to the debrief. This is where we take a peek behind the curtain. Let's connect the work we just did directly to the official mark scheme to see exactly how an examiner gives out those 4 crucial marks. Okay, now check this out. Your first method mark, that M1, you get that just for setting up the elimination correctly, multiplying the equations. Then, you get your first accuracy mark, A1, for finding either x or y. See that? You don't even need both yet. Then, you get another method mark for correctly substituting your value back in. And that final accuracy mark, that's only when you have both x and y correct. It really shows how every single line of your working is earning you points. And that brings us to maybe the single most important bit of advice on the whole exam paper. You must show all your working.
As we just saw, your method, the journey you took to get the answer, is worth half the marks. So even if you make a little slip-up and get the final number wrong, showing a solid method will still get you a ton of credit. So please, always write it all down.
And there you have it. That's how you can confidently walk into an exam and solve simultaneous equations for full marks. But I'll leave you with a final thought to chew on. We used the elimination method today, which is great, but it's not the only way. What other methods do you know? Like, could you have used substitution to get all 4 marks here? Thinking about different paths to the same answer is a fantastic way to really deepen your understanding.